Hey everyone, and welcome to another Dapr community call. It's number 112. It's October 2nd, 2024, and I'm Mark Duiker, one of the community managers. We're streaming live to YouTube, X, and LinkedIn. YouTube works best because then you can use the chat, and we see all of your chat messages there, and we can also respond there via the YouTube chat. So YouTube is the best place to follow this community call. So let's have a look at the agenda for today. So first up is Jeroen Schneider talking about executing a durable workflow for reservations with Python. Then I'll give a short Dapr update again because it's happening in 2 weeks, and that will be the celebration that Dapr is 5 years old. And then, as usual, we'll do the community show and tell. But let's first move on to Jeroen. So welcome, Jeroen.
Yeah, hey Mark. You can hear me, right?
Yeah, I can hear you. We don't have like a visual yet, but
Okay.
I can
Yep,
hear.
yep. Hello.
Yes, hello. Right, welcome. I will stop my screen sharing so you can share your own screen.
Yeah, no problem. Let's try and present here. Hi everyone. For those of you who don't know me, my name is Jeroen Schneider, Dapr core maintainer and steering committee member. Happy to be here today to talk about a topic that I really like, which is Dapr workflows. So let me share. I'll just go off cam and share my screen. Let me know when you can see it.
Yeah, we now have the, yeah, there is a demo.
Yep.
Check.
Okay, cool. All right. So today we're going to talk about how to use Dapr workflows with Python. And I'm going to be using an application here that I took and rewrote into Python from JavaScript. And this is a reference application that AWS has on their website. So actually, let me go and show the website here, because this is a pretty nice example of using step functions on AWS. And there's an architecture here. It basically shows you, how you use Lambda and SQS. So, like very, very familiar AWS services to basically come up with this workflow. And this is great, only it's really tied into Lambda. So if you're running in a containerized environment, for example, Kubernetes, and your main point of compute is containers, and you're running out of containers, and your ecosystem is for containers, and you don't want to necessarily stand up separate infrastructure, talk Lambda, or necessarily use DynamoDB, but you want to plug out your own database, then other workflows as code engines are a great fit for this, to be able to create these workflows that basically retry automatically and handle failures, but that are not tied to any specific managed service, and are really great for portability. And Dapr has that. It's called Dapr Workflows, and yeah, let's talk about that. So I'm going to go back into the slide. I'm going to talk about the same diagram, but for some reason I really like it on this slide here. Yeah, just makes it a little bit bigger. So this is the reference architecture that you see on AWS. It's a pretty simple workflow. It's a flight reservation system. Something starts the workflow. Now, this can essentially, be anything. We will talk about really good ways to start workflows with Dapr, because Dapr actually gives you a really great option to not only write the workflow with Dapr, but also make sure that you use Dapr to talk to things that might kick off the workflow, right? So Dapr has the concept of binding, and binding in Dapr is a way to talk to third-party systems. Imagine, a Discord message starting the workflow, or a message coming from Kafka, which might be using Dapr PubSub, or a binding, or you might write your own binding to basically invoke the workflow on an event that's coming from some proprietary system that you have. So this is our starting point. With the AWS example, this is usually done via an HTTP request to a Lambda function. But Dapr workflows, being part of the Dapr ecosystem, can give you a whole wide range of bindings and events that will kick off the workflow. Now we start with reserving the flight. Then we move on to reserving the car, processing the payment, confirming the flight, confirming the car, and each one of these steps has a compensation activity. So a compensation, Saga-based workflow, is something that runs if your workflow fails. So you have these refund payments, a cancel rental reservation, and at any point in time, we need to make sure that if any of these activities do fail, that they actually retry. So in the end, once this is successful, we basically send an upstream notification via Amazon SNS, and I actually really like that AWS did that. Why do I like that they did that? That they basically involved a pub sub messaging event here, because oftentimes you will go to certain technologies or certain projects or products that give you workflows as code, and you will basically see something like messaging that positions the entire workflow as the only way to achieve things. But this is hardly the case. You can't just have a workflow. You can't just have something coordinating your activities. You also need to, in the end, be able to, first of all, talk to third-party systems, talk to other services that you control, and in the end, basically fire off notifications. The workflow engine doesn't really do that. It's not in charge of communicating with whatever it is you need to be communicating for. For example, if you're resuming a car rental payment, you might reach out to a third-party HTTP API to reserve the car. And you want to do it securely, you want to do it reliably, you want to be able to put circuit breakers to make the entire activity more resilient instead of having the workflow just retry it if it fails, because, I mean, come on, we are paying for these things. So I really like that they put Amazon SNS here, because oftentimes, as I said, you will basically not see like this combination of orchestration and choreography here. So orchestration and choreography, of course, being respectively, workflow-based orchestration and pub sub systems. But there is no reason why these two things cannot be joined. So for example, you can actually start a workflow with Dapr for messages that are coming via PubSub. Then you kick off the workflow, and at any point in your activities, you can actually use PubSub again, whether with Dapr or without Dapr, because it's your activity code. You can do whatever you want in there to send the message to an upstream subscriber. So we have this thing here, and it's saving state in this case in DynamoDB, because this is the recommended way of doing things. As I mentioned earlier, Dapr has a wide range of state stores that it support: CockroachDB, Postgres, MySQL, DynamoDB, GCP Firestore, Azure Cosmos DB, just to name a few. And you can basically swap them out. And what seems interesting in combining workflows with a very swappable model of a state store is that you can basically try out and see what gives you the best performance, and you can then see what also costs you money, whether you're running it yourself and paying for compute, or whether you're running in a cloud provider. And if you're a multi-cloud shop, then, of course, this gives you a really good option of not needing to maintain multiple code bases, but essentially having a single entry point into your database, which is the Dapr API. So let's go into a demo. I am going to go into VS Code here, and I will show you where to find this code. You can run it with actually 2 lines of CLI, seriously, commands, just 2. And I'm going to start fresh. Actually, before we do any of that, if you've seen my demos before, I like to really start from scratch. I don't have Dapr installed. So as a person coming in completely new and fresh to Dapr, what do I need to do? Well, the only thing that I did do is download the Dapr CLI. And, I assume most people watching this can basically Google download Dapr CLI. Then you will have a link. You can just do brew install Dapr if you're running on Mac. It's fairly easy. So the only thing I have here is the Dapr CLI, and we can see that they don't have a runtime version because we don't have Dapr installed. So the next step, and the only step to get Dapr running, is just...
Sorry, Johan, for interrupting, but can you increase the font size a bit?
Yes, yeah.
Super.
All right. And you can see the terminal moving, right? Because sometimes I have issues with that.
Yeah, that's good.
Yeah, cool. Yeah. So I just did Dapr init. That took about 4 seconds to download Dapr and set it up on my machine. We can see that it installed Dapr 1.14.4, which is the latest and greatest. And now I can just do Dapr version again, and we can see that we have the runtime version installed. So this is essentially all I need to do to get up and running with Dapr. I'll talk about this sample later on and how to run it. But for now, let's just go over the code. So this is how my code is structured here on the left, and I'm going to zoom in.
Can you also zoom in? Yes. Perfect. Yeah, thanks.
I'm going to make it a little less comfortable for me, but I'm not what's important here. It's the people watching this. So we have one app.python app. This is like the workflow for the workflow. This is the main entry point for my app. We'll go over this. And then I have the activities for the different flight reservation activities that we saw earlier, that I rewrote from JavaScript's example from AWS to Python in this case. So, reserving a car and a flight, success, payment, and confirmation. Let's start out with the main entry point to the app. So the first thing we'll see here is, and I'm going to scroll all the way to the bottom, 78 lines of code. And this is just a regular Python web server. Nothing special, just listening on 0000. I can use whatever web server I want. And I don't actually have to use a web server to use Dapr workflows. This could just be a Python script starting the workflow. But the reason why I do have an app server here is because I'm going to be using an HTTP post request to kick off the workflow with a JSON sample that I'm going to fire off for a reservation. So it's just a way for me to kick off the workflow, but I really don't need to have an HTTP server or a web server in any case. The way, by the way, and I'm just going to get a little bit technical on this, the way the Dapr SDK for workflows operates with a Dapr sidecar is via streaming gRPC. So when you're using Dapr workflows, you don't need any ports in your applications. You don't need a gRPC web server. You don't need an HTTP web server. You can get very, very basic. It can be a TypeScript script. It can be a Python script. You don't really need anything. So in this case, we basically have the workflow runtime. I'm importing a bunch of activities, and we have Flask, of course. So these activities are everything that you're seeing here. These basically are very granular business logic. This is essentially my business logic. This has nothing to do with Dapr. The only Dapr import that I have here is the Dapr workflow extension. And I'm just using these 3 lines of code to set up the workflow runtime and then start it off. Okay, so this is how simple it is to basically just initialize the Dapr workflow engine. 3 lines of code. It will be the same across all of our SDKs. It really is that simple. And then this is my one and only HTTP method that I have on my application, which I'm just going to use as an event. This is going to be the start of the workflow. As I mentioned before, this can be an event coming in from PubSub, can be a Dapr binding, just firing it off from a Discord event, and an X event, whatever system that you're integrating it with, or it can just be an HTTP call, as we're seeing here, or even a gRPC call or a WebSocket call. Yeah, can be anything. And then we're essentially getting the request, and what we're doing here in line 20 is we're scheduling a new workflow called task chain workflow. This is the method here, which is named reserved flight. This is kicking off the entire workflow, and we'll see what it does in a sec. And then we are waiting for the workflow to complete. This is what we're doing with wait for workflow completion. And once this workflow is complete, we are returning done to the caller. Okay, so this is a synchronous invocation of a workflow. We're getting the request, kicking off the workflow, letting it work, do its job, and then just notifying the caller once it's done. And this is the main definition of what our workflow looks like. So as a developer, this is extremely beneficial because I can model out my entire workflow in just sequential calls. Now, Dapr Workflows supports a lot of different patterns, right? You can have sequential calls like you see here. So you have an activity to reserve a flight, a car, a payment, and this works, as I said, sequentially. If any of these activities fail, Dapr will save the state. It will kick it back up again, retry it, and make sure that it runs to completion. But if you wanted to, you could also execute parallel activities, which is really nice because it gives you like a map reduce type of functionality that you can do on the fly. So you can kick off multiple activities that talk to different third-party systems or your own services or what have you. And then you aggregate the results, you feed them into a database or send them off to a PubSub, and then you can basically parallelize a lot of your work. So Dapr also gives you the option at any point in time to pause the workflow until there is a third-party intervention. And this can be made by a human or, today via, for example, an AI workload that has an agent that is kicking off a task and then basically finishing the task. and then notifying your workflow that it can continue. So we're talking about a lot in the workflow world today about human intervention, but we're going to be seeing a lot of AI intervention coming up. And for Dapr workflows, this doesn't matter. It's an external signal. It doesn't know, like for Dapr workflows, it's passing the Turing test. A workflow operated by a human or a workflow operated by an AI is the same thing. As long as it sends a signal and tells it to continue the workflow, it's all good for Dapr workflows. And then we basically catch an exception here. So this is how you do your compensation. Just to keep this simple and understandable, I didn't go into creating the like different compensation activities for each one of them. But this is an example of how you would actually perform a compensation activity. So you would catch the exception, you would basically get the details in the exception about which activity went wrong, and then you could basically call off the corresponding compensation activity for the activity that failed. The only part that is left now, and this is all fairly simple, as you can see, 16 lines of code, are the different activities. So this is reserving a flight, this is reserving a car, and you can see that this is also very, very lightweight. We're just printing out the different steps in the process and then handing it over to our business logic. So this business logic here isn't Dapperized in the workflow sense. This is essentially an activity that will be retried and made fault tolerant and stateful by the Dapr workflow engine. So let's take a look at a few of them. I'm going to go into activities here, and yeah, let's look at reserve first. So reserve, I kept it fairly simple. We're getting the input. This is the JSON that we got. It's looking for a location. If there's not any location, then it's raising an exception, and this will return it to the application where it can basically retry, and then the workflow will kick off again with the location. But if the location is there, then it's adding an ID. It's basically generating an ID for a reservation and returning the input. Here we have a reservation for a car. And so we only support compact cars right now because I'm going to be kicking off a workflow to reserve a flight in Spain. So, want small cars there. So this is what it's going to do for that. And this is a payment conversation, activity. We basically are setting the payment process as true, and we are using Dapr to actually save the state. So, if someone's processing a payment, you might also need to interact with external infrastructure. Again, this is your code. You're in full control of what's happening here. You can save the state with Dapr, and you can save the state without Dapr. Of course, I'm saving the state with Dapr because it literally makes it a single line of code. So I'm basically just taking the JSON. Dapr has a key value API where you can basically save schemaless sort of data there and hook it up into whatever data store you want. I'm running locally, so it's going to be Redis, but you can hook it up into the state store that has your workflow state, or it can be a completely different state store. Another really flexible point with the Dapr ecosystem. You don't have to use the same database for your workflow and external state. These can be totally different. For example, if I wanted to get really granular, I could decide that I have a separate database for saving payment data and a separate database for saving the car reservation data if I wanted to. So we're getting this option of using completely different databases or using the same database. So this is basically just going to save that payment. This is the reservation activity that we looked at earlier. And then we have confirmation. So how do we confirm? Is if the payment is processed, then we are basically setting this to be order completed. And this is a confirmation for the car. If there is a car, then we're setting a reservation ID. And we're basically just randomizing a string here. So the last step of this is the success activity. The workflow has completed. We reserved the car, reserved the flight. Payment has been confirmed. This is great stuff. Now we want to save the state in an external state store, and we also want to use PubSub to publish an event to let some other service sitting anywhere in the world know that the reservation was successful. So in here, I have 2 lines of code. Line 9 saves the state, and line 10 publishes the event to a PubSub. And again, this can be any PubSub component. I'm running this locally, so I'm using Redis. But with Dapr, we support over 20 of these pub subs. You can use whatever pub sub you want: Kafka, RabbitMQ, SQS, SNS, you name it. Mark, am I good on time?
Yes, definitely good on time.
All right,
Yeah,
cool.
yeah, yeah.
So as you can see, these are both two separate calls. They are not orchestrated as a transaction. Dapr does actually have something called Dapr Outbox, or the outbox pattern, which allows you to treat saving state into a database and publishing a coordinated message as a single transaction. I'm not using this here, just to keep it simple and show you multiple implementations of the Dapr API, because in the outbox, you only save state, and Dapr essentially takes care of publishing the message on your behalf once the state is saved. So Dapr can actually commit a single transaction over a wide combination of a large combination of databases and pub subs. But for the workflow sample here, I'm keeping these separate. Even though you can think of this kind of as being semi-transactional, in the sense that this is a workflow activity. If this activity fails, for example, saving state, Dapr workflows will make sure that it gets retried. And so this will eventually retry until both the state is saved and until the pub sub event is also sent. But for example, if you have another service that's listening on the state store or is pulling from the state, and you cannot in any mean or in any way, shape, or form allow the data to be saved without, the data to be saved without the publishing event going out, then you would want to use Dapr Outbox to basically ensure that you have that guarantee that an event is going to go out as soon as the state is saved into the database. So this is the final notification here, and the only thing that's left here to do is just run the thing. So how easy is it to run this with Dapr locally? As we saw earlier, I kicked this off with the Dapr CLI. I have Dapr running, and this is essentially just what you saw in VS Code here. It's that terminal. And I'm going to use Dapr run. So this is the command I'm going to run. This is all you need. Dapr run is a CLI for local dev with Dapr, and it essentially runs the Dapr sidecar locally. And in this case, I'm also running the application itself after I'm running the Dapr sidecar. So as I said, we have no ports needed here for Dapr to interact with, only for the HTTP call that I'm going to make into my app to kick off the workflow. So I'm only giving my application an application ID. This is important. This is a Dapr concept. Dapr gives applications unique identities. And this is really good for security purposes, isolation purposes, data governance, and making a whole wide of things multi-tenant. In this case, I'm essentially scoping this workflow that I'm going to run to this application ID, and this is my app that is going to be using this Dapr sidecar. So let's kick this off, and we're up and running. As you can see, Dapr is fairly quick. Took it, I'm highlighting this, 9 milliseconds to initialize with a state store, with a workflow engine, and everything. I can, in this session, I can see both Dapr logs and application logs. This is really useful from a developer perspective because I don't have to do, app logs independently of my Dapr logs. I don't need to go into Docker containers and look at their logs. I have one session that basically outputs everything. Now, this can get noisy if your log level is getting to something like, verbose or debug. But if you're running with info and error, which is fine in most cases, it should work really well for you and give you this, single pane of glass to see what's happening from your application perspective and your Dapr perspective. So we can see that this is running. Dapr and my Python app are both running. And I'm just going to go into Postman here. And I'm going to kick off my application. This is not a Dapr URL. This is just my Python Flask application. It's called Reserve Flight. This is what the URL is called. And I'm just going to kick off, a name, hello there. Very normal name for a person to be named hello there, I know. Location is Spain, and we want a compact car class. So let's kick this off, and we're already getting done. Entire workflow started. Dapr coordinated. It took it 107 milliseconds to coordinate, including saving state multiple times, saving the state in the Dapr workflow engine, and publishing a message to a Redis pub sub. So this is extremely fast. Let's go back into my code here and see what happens. So we can see my application logs being outputted here. This is the first activity that comes. So let's take a look at the JSON here. I basically received the input. Sorry, this is the one. I'm highlighting it right now. Reserve flight. We received the input. This is exactly what I sent with my application. Let me just zoom in a little bit here. This is the JSON I sent using Postman, and then it was enriched because if you remember, the first activity essentially adds an ID. This is what I'm highlighting here. So this activity completed, then pass it off to the next one to reserve a car. Then when we're processing payment, we can see that the updated state is that we have an ID. Now we have a car, that's a small car. Then the flight confirmation, we can see that payment was processed after we processed the payment. So we're confirming the flight, passing it off to confirming the car reservation. I could flip the order, by the way, if I wanted to. This is just how I did it from the AWS example. Payment is processed and we're adding order completed. Now we're notifying on success, which essentially involves writing the state to a separate data store. This now has the car reservation ID that I'm highlighting here. And we're also sending it to the Dapr PubSub component. So if this would have failed, we would have seen an exception here, but it didn't fail, so we're all good. If it did fail, Dapr would essentially pick off from that activity alone, and it would have only retried from that step instead of retrying the whole thing from the start. So this is really, really nice. It's essentially very, very easy way to operate very, very complex infrastructure, because the amount of code and infrastructure that you need to write and coordinate and orchestrate and monitor and keep to get this level of APIs to coordinate your infrastructure is very, very big. And Dapr essentially gives it to you as very simple to use SDK method calls that you can use from whatever language you want. We support today JavaScript, Python, Java, C#, Rust. Thank you, Mike, for adding Rust. Yes, and more coming, and Go, and Golang too. So the workflow is completed here. We are seeing that Dapr itself also output a message saying orchestration status completed. So if you are extra paranoid and you want to make sure that from the Dapr perspective, everything is looking right, and you're a platform team or an infrastructure team, you can essentially get these log lines and get this status here, which is guaranteed not to change because it's a status code in Dapr, and you can basically just use those to make sure that your workflows that you're kicking off are orchestrated. Dapr also has error codes that it spins off if the workflow did not run to completion, so that you can basically fix your Eye of Sauron on the problematic part in your workflow, which might be an activity that's failing. So how do you get about running this thing locally? The code for this is essentially here. I showed this in a webinar a few months ago for a service called Catalyst, which is essentially a fully managed version of this workflow. This is not what we're doing today. We're focusing on Dapr open source, but this sample can actually work out of the box with Dapr without any changes to the sample itself. So you can find that one here. And if we go back into the code here, you can go into the README. So if you want to look at the Catalyst system, which is fully managed Dapr workflows, go ahead. It's great, but this is not what we're doing here today. So to get this up and running with just Dapr, you will want to go here where you're launching your Python 3 app. This is the curl command that you're running locally to run this. This remains. You can just use this curl command. But the only thing that changes is this command is now turning into this command. And I will actually add it to the sample here. So let me just copy paste it in here. So this is essentially the only thing you need to do to run this with Dapr. So run with Dapr binaries locally. And yeah, this is it. I'm going to hand it over to you, Mark, now, and take any questions if there are any. I can't hear you.
Yeah, I was muted. Thank you. Thanks a lot, Jeroen, for this. It's always good to see these workflow samples. I'm also a big workflow fan. I don't see any questions from the audience, but I do have like one question, maybe a suggestion. Can you explain a bit what happens when the workflow executes, right? Because it actually executes like multiple times, so you do have to be mindful of the type of code that you write. Can you share a bit about that? Oh, and now I can't hear you.
Now I'm muted.
Yeah.
The only thing you really need to be aware of is that your workflow gets modeled as activities, which is extremely natural for a developer. And you also need to be mindful that Dapr will retry these activities automatically, and it can keep its state if you're providing that state to the workflow engine. I would say that in a lot of cases you also are talking to external states, so it's important to note that if you're relying on state that you're storing externally, not within the Dapr workflow engine, to kick off that state, then you want to probably make sure that it's transactional if you're operating for multiple instances. So yeah, just be mindful of your external state invocation if you're doing anything like that.
Yeah, and try to wrap all of these things in activities, right? So don't do any
Yes.
verification
Yeah.
calls directly from your workflow or any.
Yes, if you're using Dapr workflows, make sure that everything's an activity. That's how Dapr guarantees that everything gets executed, retried, and it basically gives it full tolerance and whatnot. So you can actually use Dapr workflows, for example, to talk to other services that are not using workflows. But then your workflow will treat those external communication as steps that it needs to retry.
Cool. Yeah. Thank you for this clarification.
Yep, no problem.
All right. Thanks, Ron.
Yep.
All right. I'll share my screen again for the next topic, and that's a quick Dapr Day update. We already mentioned that the agenda is now online for a couple of weeks. This is just a reminder. At the moment, we have just slightly over 250 registrations for Dapr Day, which is already a great number. But I'm really hoping for even more registrations. Let's have a look at the lineup. So we're Sissel and I are hosting this event. So we'll do some announcement and then Mark Rustinovich will do the opening keynote for us. And then we have Alice Gibbons and Aaron Olds doing a session about Dapr and Kubernetes. It's a sharper image experience from the trenches. So that there are definitely a lot of sessions that really are very practical with lots of production and knowledge. So I think this is really valuable for a lot of people. The next one is also really a practical one from CD Pharma about processing 1 million data points daily with Dapr. So it's also really from his experience at Microsoft. Then we're going to do a reasonably big Dapr community announcement, which I cannot share yet. You really have to join Dapr Day. Then Mark Lefter will tell us something about event sourcing and CQRS capabilities in Dapr using bindings. I think that will be a very popular session as well. Then Alex Mang will again give us some tips on running Dapr in production. Then we have Roberto Rodriguez talking about Floki. It's a new application he wrote about building agentic workflows with Dapr. And then we have Harry Kimpel talking about Dapr and .NET Aspire, very popular way to do cloud native development with .NET these days, but more focusing on observability. Then we have Elena talking about Dapr actors, and then again a very practical real-life talk about building real-world applications with Dapr, a startup developer's journey with Waldo. And then we have the closing keynote by Joe Beda. So yeah, as you can see, quite some big names which we're very happy about, and lots of practical information about people who are running Dapr in production. All right. Let's move on to the next section, and as usual, that's the community show and tell. So we have quite a lot of blog posts written in the last 2 weeks. The first one is introducing the new Dapr Jobs API and Scheduler service, written by my colleague Cassie Coyle. So this new Jobs API is really nice. It's still in alpha because it's very new, but please definitely check out this API, and this blog post is a great way to get you started with that. Then there are like several blog posts from Roshan Gavandi, all about Dapr and also some Azure services. So definitely have a read through those if you're using Azure. Then another blog post on .NET Aspire and Dapr by Tommaso Storci. And finally, a blog post about Dapr in the cloud with Catalyst public beta, also the service that Jeroen mentioned just now by Mike Elsmore. Then we have also quite some videos on YouTube. The first two I want to highlight are some that we are recording for the Dapr open source project. We interview some Dapr end users and ask them some questions about their Dapr experience. So the first two videos are now online. That's one with Miroslav Janeski and one with Gilles Vlies. So please have a look into those. And then we have a couple of videos from Cloud World. They were also in the previous community call with a video, but they have created more videos with Dapr, also mostly focused on Azure. Definitely have a look. And the final the two from Dygit, one about production readiness about your Dapr applications with Dygit Conductor, and one where the new service Dygit Catalyst is introduced. And finally, it was a recording from a conference, one of the NDC conferences in Oslo, where Mark Klefter shares his experience about running Dapr in production. So quite a lot of Dapr videos online, so definitely have a look. And here are some samples of social messages. In this case, just what I found on LinkedIn. A lot of people sharing Dapr knowledge there. Again, also sharing some Dapr and .NET Aspire information. This is actually the blog post that I cross-posted to DZone. There's also someone, Anssi Panula, doing a session in Finland about Dapr. And this is actually quite interesting. So for all of our Spanish speakers, apparently there's a LinkedIn learning about using Dapr in .NET. So yeah, if you're speak Spanish and also English, please follow this course and let me know what you think about it. I'm quite curious. So if you are writing something or recording videos about Dapr or doing presentations about Dapr, you can claim these Dapr badges. So if you want them, you have to go to the Dapr community repository and there update one of the two markdown files where you just add a line that links back to your blog post, to your video, or to your presentation. And then we will give you a Dapr badge. And you all can claim one of these Dapr badges because you're watching this live stream or YouTube video later. So that's it. Let me know if there are any more questions. Otherwise, I would like to invite you for Dapr Day. So that's happening in 2 weeks. So in 2 weeks, there is not a regular Dapr community call, but then we have the Dapr Day, which like several hours of content with lots of great speakers I just announced. So I hope to see you all there. Until next time, everyone.